Ptolemy's view of the universe, as most of us are aware, involves the Earth at the center and everything revolving around the Earth. It's so good to see the students have to wrestle with those things. It gives them a greater appreciation for a thinker who is, yes, in many important ways simply wrong, but to whom we're greatly indebted. You've got to start taking it seriously because they're going to bring forward powerful arguments and then whole branches of mathematics that are undergirding what they're about. The thinkers who later come and correct him are themselves responding to the kind of work that he's been about. All right, Chris, here we are with Ptolemy, the ancient mathematician and astronomer, lived in the 1st century AD. I've been teaching the sophomore mathematics tutorial here for the last few years, and it kind of kicks off a whole sequence of classes here. So we look at Ptolemy, followed by Copernicus and Kepler in sophomore mathematics. But then junior natural science in our program takes up Galileo and then Newton. And in a way, all of these thinkers are concerned with giving an account of the physical world in its largest view. And in particular, what's going on with the heavenly bodies and their motions. So talking about Ptolemy kind of initiates this big question as to what we're doing here with this entire sequence of courses. So why study Ptolemy is a natural question, especially given that Ptolemy's view of the universe, as most of us are aware, involves the Earth at the center and everything revolving around the Earth, and the Earth itself remaining motionless, which is often just referred to in a kind of antiquated, dismissive way as the geocentric theory. But we spend an entire semester with Ptolemy. So I think it might be good for us to think about why we do this. He himself gives reasons for why he thinks it's more important to study what he's doing, but maybe beginning with why we study Ptolemy would be a nice starting point here.
So why do we do it? I mean, I think the primary reason is implied in some of the things you said, that this is one of the great theories about the order of the universe. And it's not just a bunch of assertions, right? It's actually a carefully articulated and mathematically worked out and empirically grounded theory about the whole order of everything above the Earth, right? And implicitly about the Earth as well, insofar as the Earth's immobile and everything's revolving around it. And in other words, the scale of this work is itself makes it worth reading closely and thinking about, not just for what it's talking about, but because of how thorough it is of a theory. Right? The name of the book's called the Almagest, which I think is not his name. It's some Arabic name that originally means something like the great work, or something like that. And I think he might have called it something else, like the synthesis of astronomy or something like that. And so this is a great undertaking to see, to say something intelligent about the universe as a whole, and to actually have evidence behind it. Again, he's mistaken when he thinks about the Earth as at rest and everything going around it. But he's got the observations and the math that allows him to make it, to take the way things appear, which is that the Earth's at rest, right? It does seem that way, and make a theory that will explain all the previous observations of the planets and the stars and the moon and its phases and the sun, of course, and predict what the next observations will be, right? And he's able to do that just based on the careful observation of the past and of the present, and figuring out what the math has to be if the Earth's at rest and everything's moving in perfect circles around the Earth. He finds that he has to manipulate the math a little bit, not in the sense of falsifying numbers, but in the sense of making the geometry of the theory more complex. But once he does that, he's able to tell you when the next solar eclipse is going to happen, right?
Yeah.
And where it'll be visible. And that makes it a spectacular theory, even if it's spectacularly wrong in certain ways, right? And it may be the most fundamental way in terms of what's moving, right?
Yeah. It strikes me that even this notion as to why study astronomy, because that's really where this takes us back to.
Yeah.
And you see it sort of hailed in some of the ancient philosophers even prior to Ptolemy. So, for example, Plato
And Thales.
assigns, they assign heavy weight to the study of the heavens. And one of the ways I've tried to remind students of the significance of this sort of thing is by asking them to imagine, look, if you're sitting in your house one day and someone came up to you and said, hey, you've got to come outside, I need to show you something. There's something outside that has actually been there for over 1 million years, and it hasn't changed what it's doing. It's doing the exact same thing it's done for thousands and thousands of years. You'd almost think this is quite literally something from a different dimension, right? A different kind of being than what we're just used to interacting with. And of course, that thing is out there, and it's the sun, and the stars are like that, and the planets. To all our observations, there are these individual things that we can see that have just done their thing for longer than humanly recorded history.
The constellations themselves. I mean, the fact that we can point to the Orion constellation now, and it looks the same as the way the Greeks saw it, right? Which 2,500 years ago, right? That's extraordinary. They seem pretty darn eternal, right?
Exactly. Yes, and that's Ptolemy's opening principle here, is that part of the great worth of what he's doing. Now, he really thinks there's something divine or quasi-divine about these realities, because, as you say, that's the way they seem. That's the way they appear just to our sort of unaided, native human experience of them. Students often find it difficult to inhabit his worldview. But what's interesting about their experience, and I include most of us who aren't professional astronomers in this, is that we're kind of bifurcated. On the one hand, we're the inheritors of so much terrific astronomical knowledge. And so we each possess an extraordinary amount of information about the universe. And yet, it's not as though we have done any sort of intellectual work or observational work, to evaluate this information. So we're also, in a way, like little children in that sense. But Ptolemy is in some sense the reverse. He stands at the dawn of an age of inquiry into the heavens, and yet what he's able to do, the amount of observation and the mathematical figuring that's involved in his work to be able to give an account is extraordinary.
It is.
And beautiful.
And let me add something to that. When you talk about the difficulty of getting the students, first-time readers, to take seriously the geocentric hypothesis, to give it the credit where credit is due, one of the exercises we have them do is spend some time out at night, early in the year, in the academic year, so to help them take seriously Ptolemy. They spend some time noticing that it does, if you spend some time watching the constellations, identify a few and just sort of track them as the night goes forward, they do seem to rotate around us on a sphere, right? And you notice if you look at certain places, it seems like everything rotates around that. And it seems like it's as though I'm inside a large sphere with stars embedded up in it, right? And it's revolving around me. There's one particular star that everything seems to revolve around here in the northern hemisphere, right? And the North Star, right? Its position is fixed, right? And so, at least I've had an experience with students where they said, I'd never noticed that the stars are different at different times of year, right? And they always assume that over the course of the night, all the same constellations go by. And in a way that's true, but half the day they're bleached out by the sky, right? So they can only see Orion, for example, in the winter time, because it's up during the daytime, right, in the summertime. And so they'll start to notice that it starts to give the theory, even though they don't ever take it too seriously, right? They at least see, yeah, why you would think this, right? It does look this way when you do start to have some of that firsthand experience that most of us don't have, because we're not professional astronomers and don't have telescopes and can't track things for hundreds of years, right?
Yeah, that's a great point. And that's another part of the interesting bifurcation is we can't help but refer to these things in a language that's Ptolemaic. So we talk about the sun rising and the sun setting. And it would be very difficult and awkward to even try to habituate ourselves to a different mode of speech. So there's something interesting about that, the kind of unavoidability of, in a certain way, living as though the Ptolemaic
center of the
view
universe
held.
Yeah, I think it's right that astronomers who are, or not astronomers, sailors that are taught celestial navigation, and when they're taught to use the stars, knowledge of the position of the stars, to determine their position, mainly their latitude, they're taught that they study it as though the Earth's at the center of the universe. They're taught the basics of Ptolemy's astronomy because it actually is useful to approach things as though we're at rest and everything's rotating around us on a giant sphere. You can tell how far north you are, based on position of the North Star primarily.
Yeah, and when you're talking about spheres and circles, those are simple forms. Those are geometrically, well, they're beautiful, but also easy to work with. And it's also important just for us to know and to keep in mind that although we do end up discovering with Kepler, for example, that the paths of the planets are actually elliptical and not circular, the amount by which they're off of circularity is minuscule. And so if you were to look at these orbits just as if they were presented to you externally, you would take a look at them and you would say, oh, that's a circle. It takes an immense amount of observation just to be able to see that they're not circular.
Yeah, I think it's right. If I remember right, it's serendipitous that Kepler, I don't want to get bogged down in Kepler, but Kepler picked Mars for his study, and it's the most elliptical of the 5 most observable planets.
That's right.
And that percentage of ellipticality, if that's a word, right, is something like 2% or something like that.
It's less.
Yeah, it's less than that. So the way it diverges from a circle and actually becomes skinny, like an ellipse, right, is just insanely small. And he had tremendous observations, so he could actually detect that after some careful, maybe years of study. But you would think it's a rounding error. You would think, surely it's actually a circle. Someone just made a mistake here, right? Because it's so close to a circle.
And that gets into another facet of the worth of studying Ptolemy is that it has to do with maybe a larger point about scientific inquiry as a whole, that, as we'll see, the Ptolemaic model, so it does justice to our initial experience of things and the effort we make with the observations with the naked eye does seem to give rise most immediately to a Ptolemaic model. But then as Ptolemy increases his observations and sees more and more of a need to accommodate phenomena in the heavens, he needs to introduce certain things to his model. And then those things become more and more awkward and create tensions in the model, which later thinkers like Copernicus want to respond to. So there's even some question as to whether, well, to what degree to Copernicus's insights come out of a response to Ptolemy. And so that,
as if to say, maybe Copernicus couldn't have made his discoveries unless Ptolemy made his first, or made his mistakes even.
That's right. That's right. I guess that's what I was trying to say, in a nutshell, is that there's something important. It's not just that Ptolemy is one guy who tried to figure it out and he's wrong, so why do we even consider him? But rather, as it happened in the course of human history, he was an essential player, even though the bulk, the kind of grand view that he had in mind was incorrect.
That's right. And I think the level of the complexity of his observations, the care with which he made them or gathered them from other people, and with which he worked out the math, was so thorough that no one exceeded him for about 1,500 years after he wrote, 1,400 years maybe, over 1,000 years, if your math and your observations are that good, and they seem to not yet be refuted, that's a pretty good sign you're onto something. Now, as a matter of fact, he's not. He's at least his idea of what's at rest, anyhow, is deeply mistaken. But you can see that that, I guess, just as further argument for the greatness of what Ptolemy did, is that the math and the observations carried the day, right, for several hundred years.
Yeah, that's right. And for our students, it's interesting to see that mathematical dimension of things in particular.
Yeah.
So during their freshman year, they're looking at pure geometry, Euclid's Elements, almost the whole of Euclid's Elements, which is an amazing work in itself, but it's abstract geometry, and it has no connection with any kind of immediate application to the physical world. So Ptolemy is the first thinker that our students look at who even develops aspects of mathematics precisely for the sake of better understanding the heavenly bodies.
Yeah.
And
you're thinking of like the Menelaus theorems and the tables of
the
chords
tables.
and
That's
and,
right.
Arcs.
Yes, yes.
Yeah, and that's like primordial. That's the beginning of trigonometry that he's working out there by associating arcs and chords. And doing it in such great detail. Right?
That's right.
It's an advance ahead of Euclid, I think. Yeah.
Yes. Yeah. So Ptolemy himself regards what he's doing as an especially important form of intellectual inquiry.
Yeah.
He tells us at the outset that to know, he holds that there is a God, a first mover of the entire universe, but to hold that we could have any insight into what God is in himself or in itself is something that's just too much for our mortal intellect.
Yeah.
So he says instead, what we can do is to look at his works, look at his effects, look at the motions that he initiates in the cosmos, and try and understand those mathematically. And so, in some way, what he's proposing here is a kind of theology.
Yeah.
Which is astonishing.
Yeah.
We don't think of math or astronomy that way,
No, yeah.
and yet that's in large amount what this amounts to for him.
Yeah.
And then on the flip side, this is a superior form of science to what he would refer to as something like physics, which would be a more humble investigation of the realities immediately around us. So,
immediately, yeah.
physical material qualities like moisture and dryness and hardness and softness, and the kinds of characteristics that we attribute to the physical world around us. And he says that those things don't admit of enough intelligibility.
Yeah.
And so
there's too much chance mixed into how things happen in the natural world, meaning the world that's immediately within our senses, I guess.
Yeah. So there's an interesting proposal here as to what a paradigmatic form of scientific inquiry could look like. It's in some way got the highest accessible object to us in the cosmos, but also the most superior form of reasoning is involved here, which is, for him, mathematical.
Yeah, I think that's right. Yeah, and the very fact that the things you're looking at, as far as you can tell, are eternal and are not immobile, but never changing, right?
Yeah.
It's not as though, we had this constellation Orion for several centuries, but now it's gone, right? The stars don't burn out as far as he could tell, right? And of course you got the greatest of the heavenly bodies, the sun, right? That seems in some ways godlike in its eternity, the way it gives life to everything below us. So it's as though he's imagining that astronomy takes the best of all the sciences, right? It's better than theology, or it's a kind of theology. It's better than physics. It's better than mathematics, but it sort of synthesizes all of them into something that is, he's saying, look, this is what you want to study, right?
Yeah. Yeah, and there's an interesting way in which aspects of contemporary physics have something in common with his view. Now, obviously, the worldview as a whole is very different, but that the inquiry should be heavily mathematical for example. That's something that contemporary physics very much shares in common with Ptolemy's view. And that in some way, contemporary physics tries to give an account of the whole. And the forces or the movements, I guess you could say, that in some way would impact the whole to the greatest degree. That's also the kind of thing that Ptolemy's going for.
Yeah, I think that's right. Yeah, it's kind of a replacement for theology, at least the way physics is often thought of, is that it gives you the nature of things, right? It gives you the universe as a whole, and you have sort of the divine perspective at that point, right? There's maybe you argue about whether it implies that there's a God, but at least the physicist is saying that if there were a God, I would be seeing the nature of things the way he sees things, right? If I have successfully understood the cosmos, right?
Yeah, that's right. Yeah, Ptolemy also has an interesting claim here. This is at the opening of the Almagest, but where he's kind of offering a sort of defense of what he's doing, and he says that this pursuit would render men clear-sighted in the nobility of their actions and character because of the uniformity, orderliness, proportion, and modesty it contemplates in the divine. It makes those who pursue it lovers of this divine beauty, and it habituates and, as it were, naturally disposes them to a like structure of soul. So that in some way he thinks there's a moral dimension to this sort of inquiry. That somehow we become more like the things that we think about and that we contemplate.
I think he's getting that at least from Plato in the dialogue, the Timaeus, where Timaeus makes the same point. And so they're seeing that, that one of the benefits, you might say, maybe one of the purposes of astronomy is to get you to harmonize yourself with the universe as a whole, and the best part of the universe, namely the eternal part, the godlike part, right? And so he's imagining that there are movements in our soul, right? You think about that in terms of our passions, maybe, that need to be set in order, right? Such that the more rational ones govern the less rational ones. And there's something like that that's happening in the stars that you're trying to mimic. It's not as though Ptolemy goes so far as to say, once he works out the theory of how Mars's epicycles and deference work, he doesn't say how to apply this to your moral life or something like that. But he's saying that should be lurking in the background of your motive for studying these things. It's conforming yourself to the beauty and order of the universe. I think that's right. We had an interesting discussion earlier this semester about that very claim. And when you first read it, you realize you can't take this super literally, in the sense that, well, somehow my soul is going to resemble the planet or the constellation, but rather there's an underlying logos or order, principle of order that's present in these things I'm looking at, and that somehow that's what my soul or my mind is also characterized by. The orderliness that reason can discern and can bring about. So that, for example, even after studying something like Euclid for a year, your mind becomes more able to operate in a manner that resembles a Euclidean manner of operating. And it's come to characterize you in some way. And it's more rigorous and that's right.
So that idea isn't just kind of an antiquated notion.
There's an expression, isn't there? Something like, you become what you behold. I don't know where the expression came from, but at any rate, the things that you focus your mind on a lot will start to make you become like it in some ways. Right? And you can see that. And maybe it's most obvious in terms of things that corrupt you, right? Watching bad movies or listening to destructive music or something like that stirs you up a certain way, and we are essentially creatures that like to imitate what we contemplate and sense. And Ptolemy's saying, contemplate this, right? And you become more like it. Even things, probably worth saying that one of the things that Ptolemy's doing is he's trying to see things. If it's true that you can see fairly readily that there's a great orderliness to the way the stars progress across the sky, it's also true that there's certain things you see in the sky that don't seem to act that way, and those are the things that seem to wander out of their paths, and that was the source of the name planet, right, which just came from a Greek word, meaning wanderer, right?
Right.
So there's certain stars that seem to do their own thing, right? And it seems like they defy the orderliness of the rest of the cavalcade of stars, right? And part of what Ptolemy's doing is saying, I'm going to try to figure out whether there's a method to that madness, right? And
Yeah.
he sees that order by carefully observing them. He'll see that you track Mars over the course of the year, it'll sometimes come to a certain point in the sky and it'll stop, right? And stay there for several days. Then it'll start backing up for several days, right? Then it'll stop again, and then it'll go forward again. And he's able to explain that through a very elaborate arrangement of circles rotating on circles, which are called epicycles in deference. And it turns out those are as orderly as the stars themselves, right? So it always ends up wherever there seems like there's chaos, or at least anomalies, right? It turns out even here, there's a divine eternity, right? Because those circles are all moving regularly on each other, and they're all, at least to some extent, centered around us.
Yeah, so that harkens to what he regards as his kind of foundational principle here, which is that he says it should be a goal of the astronomer or the astronomer philosopher to explain the movements that we perceive in the heavens by means of uniform circular motion.
Yeah.
So that the actual motion or principle of motion itself needs to be that of a circle in some way, and that the motion be uniform, which is to say that it be regular, that it not speed up and slow down, but that it be a continuous same rate.
Yeah, not speeding up. Yeah, so equal arcs and equal times, something like that is how he puts it at one point.
Yeah, and this has to do with his notion that these beings that we're looking at are in some way divine.
Yeah.
They're eternal, at least to all available experience. We've never seen them come into being or pass away. Homer talks about them, just as Ptolemy's contemporaries hundreds of years later do. And not only are they eternal, but as we've said, they seem to have been doing the same thing forever.
Yeah.
So to the extent that they're divine, Ptolemy wants to say it's most appropriate for them to move in uniform circular motion.
Yeah.
It's very interesting because it's not as though Ptolemy is simply saying, well, it'll make it easy for me as a geometer to explain things in terms of uniform circular motion because circles are easier than ovals.
Yeah, right. Yeah.
And uniform motion is easier than motion that speeds up and slows down. No, he's saying this ought to be characteristic of these beings.
Yeah.
And so my job is to now come up with an account or a model that proposes how uniformity and circularity can be at the foundation of everything that these realities are about.
Yeah. It's remarkable that way that he follows out the intuition that these things are immortal, right? And again, he's not just foisting that on things, right? But he's got hundreds, maybe thousands of years of observations under his belt, thanks to the Egyptians. That he's an Egyptian himself, I guess. And they're always there. Those constellations are always there. So that leads to the reasonable assumption, right? That if they seem immortal, we should treat them like they're immortals, right? And if they're immortal, they shouldn't change. They should be moving regularly, right? Equal arcs and equal times.
Yeah.
He gets to the point though where he's got to preserve that principle. He has to do things like, first, in the case of the planets, he has to move their circular path slightly off center, right, off the center from the Earth.
Yes.
Right?
In fact, that first comes up with the sun.
Yeah, right.
Because he notices, and this can be noticed through fairly simple observation, as long as you're willing to take a year to do this. What he notices is that the seasons, so the quarters of the sun's great circle, if you want to put it that way, are not equal to one another.
Yeah.
So that the time from the tropics and from the solstices, that ought to be, each of those quadrants ought to be exactly 1/4 of a year.
Yeah, right.
But in fact, they're slightly off.
Yeah.
So that winter might be a bit longer than spring, and so on. And so how do we account for that?
Yeah.
And so that's where he
Move
does
the
what
circle.
you say. We move the circle such
Yeah.
that if we're a little bit off center, then what seems like a quadrant of motion to us is actually more than 1/4
Yeah.
of the sun's circuit. So it's
Yeah.
spent longer time on that
Yeah.
fourth, and therefore that's what makes the season seem longer.
Yeah, and maybe you should add to that, so that it turns out that there's no longer one center, right? So in other words, and the Earth stays at the center of the universe, right? But the center of the path of the sun is moved away from the Earth itself, right?
Yes.
So the sun is what's eccentric at that point, or its path is eccentric to the Earth. Yeah,
That's right.
and that's what causes those inequality among the seasons, right?
Yes. So that's where, at the outset, Ptolemy gives us a kind of view of the whole cosmos, that the Earth is at the center, because it seems like it. It seems like everything's going around us.
Yeah.
And so that's where you first see a kind of departure from the initial principle, right? Is, well, we're not at the center of the sun's circular track.
Yeah, right.
But then, yes, things get a little more complex.
Yeah.
You were talking about the motion of the planets earlier.
Yeah, so to account for any of the planets, he finds that he not only needs an eccentric circle, but he needs to have the planet moving on an additional circle, which circle rotates around that greater circle, right? So the little circle is called an epicycle, right? Just to account for the observations, each of the planets moves on a little circle, which itself is moving around a greater circle, which is itself not exactly centered on the Earth, the center of the cosmos, right? And that'll do it, though, mostly, right? That'll be very close at describing the actual observations.
And what, I guess concretely, what he's noticing in the case of a planet like Venus is that we see it over the course of the year move through the zodiac, move through the signs of the zodiac, just as we see the sun do.
Yeah.
But Venus seems to toggle back and forth in front of the sun.
Yeah.
And so what we're seeing is this kind of like linear, well, it's a circular zigzagging in front of the sun. And as you say, it's the little epicycle circle that Venus is on would account for that. If the sun is somewhere inside of that epicycle, well, Venus is doing its own little orbit around the sun, and that's what creates the appearance for us.
Isn't it right, though, that at least for Ptolemy, he doesn't want us, he has no reason to think that the sun would be inside that epicycle, right?
The actual sun.
Yeah, the actual sun.
That's
It would
true.
appear that way, yeah.
Yes.
And
Yes.
his inability to explain how the sun or the mean position of the sun seems to always put it within, say, 45 degrees of Venus, is one of the mysteries that he just sort of leaves unsolved, that along come Copernicus, he can make sense of that, right?
That's right.
Down the line.
Yeah, so you've got Mercury and Venus, which share this just coincidental fact that they both seem to be tied to the sun in that they kind of toggle back and forth in front of the sun. That is a coincidence for Ptolemy. Equally coincidental is the fact that the other three planets that he's able to observe, which are Mars, Jupiter, and Saturn, themselves have an interesting sort of relationship with the sun. It's a different kind of relationship, but it's a relationship that has to do with the fact that the sun in regular ways is conjoined with those planets and is opposed to those planets from our perspective. And there's no reason that Ptolemy's account is able to give of that kind of thing.
Is this right, that the phenomenon is something like this, that when Jupiter or one of these outer planets is furthest away from the sun in the sky, that's when it's usually right in the middle of its retrogradation, its backing up movement, right? So if the sun is setting, right, in the west, right, and Jupiter is rising in the east, that's when it's going the wrong direction, right? Whereas, so in other words, over the course of the year, they may end up near each other, right? But eventually they get further and further apart. At some point, Jupiter will stop its moving, right? And that'll be when the sun's opposite it, right, more or less, right? And Jupiter will back up, right? And it'll start going again, and that's when they'll start to, when they start to come closer together is when they seem to be most in sync in the motion. So the Jupiter goes the fastest, if you will, right, when it's passing the sun in the heavens, where it's going the slowest, or you might say a negative motion, right, when it's at opposition with the sun.
That's right.
And there's no reason for Ptolemy why that should be the case. At least he doesn't express any account or theory why that would be the case. Certainly there's nothing about the math that suggests that should happen. It's just a kind of a neat coincidence.
Yeah, and it gives rise to a very interesting question. Right? So that on the one hand, Ptolemy's way of approaching these realities maybe couldn't explain those sorts of coincidences because, well, it's not the kind of inquiry that has to do with forces and positional forces that we
and
later
causes.
come into view, causes that we get with especially Newton much later on. But we could still ask the question, well, for Ptolemy, just as a human thinker, should these have come across to him as coincidences that are in need of explanation, or might it have been that he saw these but thought, well, they're interesting ways in which there's a kind of order in the heavens, and that's just what I would expect because I regard these things as supremely orderly. So that the inner planets should be tied to the sun, and that the outer planets should be tied to the sun, but in a different way. Maybe those are interesting orders that future astronomers could look into or something like that.
Yeah, I think it's right, and again, it's again partly because of maybe this is too simplistic a way of putting it, but there's no way to get your hands on those planets and stars and the sun, right? It's just so far away. It would seem arrogant to propose a causal explanation. Maybe that would be a sort of thing that would motivate him to say, our job here is to sit back and enjoy the show, if you will, right? Just to contemplate these things and work out what the movements are going to be just based on what they've done, but just be agnostic about what the causes are that's making this happen with that, and just appreciate the beauty of it, as you said, right? Maybe that would be the kind of explanation, if you sat Ptolemy down, that he might offer. But later astronomers will go further, even before they have the kinds of telescopes and measuring devices that we have now, right? They would be willing to try to give an explanation in terms of causes, right, that are remarkably, surprisingly fruitful, right? That they actually take you a lot further than Ptolemy could. We'll have to do a later episode on Copernicus, Kepler, and probably Tycho Brahe and Newton, right, to sort of fill out that picture. But you see that with different assumptions about what's moving, right, you can make a lot of sense about certain phenomena that are just lovely coincidences in Ptolemy, I think.
That's exactly right. So switching the arrangement of things just geometrically is able to give Copernicus, for example, an intelligibility to what's going on in the heavens that isn't there for Ptolemy. That what is coincidental for him becomes just an expected part of the intelligible order for later thinkers.
Yeah, you say, of course, eureka! When you put the sun at the middle of Venus's orbit, it starts to make more sense why the movement is the way it is, right? And why the mean longitudinal movement of Venus stays within a certain number of degrees of the sun. It's because it's actually going around the sun.
Right. As are we.
Yeah.
Yeah.
And that's the next step. Yeah. That's right.
Yeah. Yeah. One of the extraordinary things in Ptolemy, and you referred to this earlier, is that despite the ways in which his overall view of the heavens is inaccurate, he's able to be so extraordinarily precise with some of his observations. So he wants to figure out, one of the first things that's important for him to figure out is the exact measurement of the year. So from the sun's path from one point, so to speak, all the way around the course of the year to that very point. And so for him, he's going to take that as one of the solstices or the tropics. So either the longest day or the shortest day or the time when you have equal nights and equal days.
Equinoxes,
right? And so you watch him go through that investigation, and it involves a lot of observation. It also involves a lot of mathematics.
Yeah.
But he's able to come up with the measurement for the year, which is so precise that it's off of what our modern atomic clocks give us by a very small fraction.
Yeah, fraction of a fraction.
Fraction of a fraction.
Yeah.
Right. We're talking about seconds within his arrangement of measurement.
Yeah, that's right. Yeah, to the point where he's able to predict when you're going to have to add extra days to the year to deal with the precession of the equinoxes, or even just setting that aside, just the fact that a year is not exactly 365 days long.
That's right.
It's not even 365 and exactly a quarter of a day long, which is sort of what our 4-year leap year cycle implies.
That's right.
But you have to add a few more days, like every 100 years or something like that. You have to add an extra day or some fraction number of days, where there's going to be 2 leap days that year or something like that. And because it's slightly less than 365 and a quarter days, right? It's just some tiny little bit.
That's right. I think it's
or slightly more.
Every 100 years you leave out a leap year.
Is that what it is? Okay.
But then every 400 years you don't leave out one of those leap years.
Yeah, that's what it is. Okay.
And he was aware of what all of that would have had to have been.
Yeah.
Yeah.
And you see his profound desire to be very empirical there too, right? People sometimes, the few people that talk about Ptolemy will say that, speak of him exclusively as a mathematician, but he really wants to get the observations just right, to the point where, although he's an Egyptian, I think there's an Egyptian tradition in his the time leading up to him, where the Egyptians wanted the math to be so simple that they thought of a year as only having 360 days long, being 360 days long, because 36 has got lots of factors, right? 360 has lots of factors, so the mathematics becomes very simple, and that's a very nice round number. 365 is okay, but it's not as Pythagorean as you might like.
And you get 12 36-degree increments that way for each month.
Exactly, right.
Which is nice.
Yeah, so all those, And so, but the Egyptians pretty quickly became well aware that you've got 5 more days you're not accounting for. And so they made up these days. They just said, those are days that don't exist. But we know they do exist, so they would celebrate for 5 days and pretend that they weren't a part of the calendar. And, they drink a lot of mead and, and party a lot. And those are called the intercalary days, right? So those are days that were like a no man's land between one year and the next. And Ptolemy didn't like that. Apparently he thought, no, we just have to keep in mind that the observations say that there's 365 days and a quarter, right, that we have to accommodate. We have to accommodate our calendar to. So I guess that's at least a nice contrast between Ptolemy the scientist and the empirical scientist, with even astronomers of his own day who wanted things to be, they wanted to stuff the observations more into their into the theory that doesn't quite fit them.
Yeah, that's a great point. He has a whole chapter where he gives us all the known habitations of Earth at the time, like for the major cities and the different latitudes, what the observations would be like from those places.
Yeah, wow.
So obviously he doesn't live in a society that has the technology such that someone in Rhodes can call someone in Athens and say, hey, this is what's going on right now in the heavens.
Yeah.
But Ptolemy makes it such that we don't need that.
Yeah.
He says, look, here's when the longest day will be for this person here, as opposed to this person there, and here's the latitude beyond which you won't have the sun pass directly overhead, versus ones that you will. And so it's like he's able to create these vicarious observers for himself all over much of the known Earth.
And presumably the people that could check that later could confirm what he saw, or predicted, I should say. Yeah,
that's right. Yeah.
That shows the real power of the theory, right? And maybe it's worth adding that it also shows that even if there's a deep mistake mixed into this, right? This is another way maybe of getting at the same point I made earlier, but and it's probably the most obvious thing in the world, but it doesn't feel like the Earth is moving, right? that it doesn't feel like the Earth is rotating around the sun, and doesn't feel like it's orbiting on or rotating on its axis. And there's the whole, if I remember right, though, maybe it's not the whole first book, but the first several chapters of the Almagest, he's just trying to convince the reader of that, as if the immediate experience doesn't suggest it. He says, let's at least shore up that opinion, right?
Yeah.
And he likes to speculate about what would happen if the Earth were rotating and how things would fly off, and those are real arguments that I think it's good for us to look at, right? Because it forces us to see how we need to have a fairly developed physics to address those kinds of arguments.
Yeah.
Right? Because it does have a sort of a prima facie plausibility that if you're standing on a surface that's rotating, you're going to get flung off, it seems. Right?
Yeah, especially one that would have to be rotating so fast.
Yeah. And he has a good sense of the actual size of the Earth, right? So he can make a case that this enormous thing rotates in just 24 hours, right? That would seem like that would produce a lot of centrifugal force, right? That would set us out into the stratosphere.
Yeah, that's one of the amazing things, is to see that, okay, he's wrong in holding that the Earth is at the center of all these orbits and that it doesn't move, and yet he knows it's a sphere.
Yeah.
He has some sense, as did other ancient thinkers, of what the size of the Earth would be.
Yeah.
They were able to figure some of these things out. And then the extraordinary predictions and calculations we've already gone through. And so it immediately disabuses a reader of any notion of these thinkers as being adherents to a kind of ridiculous view of things, sort of like, well, you don't find a flat Earth in here, for example, right? Or
that's worth noticing, that this is from the 1st century AD, or 2nd century maybe, and he has used observations to show that the Earth is spherical. That there was, and all the educated for 1,000 years and a half after this were familiar with the arguments often based on nautical observations, that the Earth is spherical. It's a really unfair that there's an urban legend, right? That it was Columbus, right, who demonstrated that the Earth was spherical, and before then, people told him not to sail west because he's going to go off the edge of the Earth. All the educated at that point in the end of the 15th century knew this, and they had known it for several hundred years, back to Ptolemy, and even before Ptolemy, because the Greeks did a pretty good job of settling that question.
Yeah.
So it's not as naive as regards the sphericity of the Earth, right, as you might guess from jingles you learned about Columbus sailing the ocean blue.
That's right. Yeah, and it's just a wonderful example of how once you actually get into a great thinker's vision and his world, you got to start taking it seriously, because they're going to bring forward powerful arguments, and then whole branches of mathematics that are undergirding what they're about. And it's so good to see the students have to wrestle with those things. And it gives them a greater appreciation for a thinker who is, yes, in many important ways simply wrong, but to whom we're greatly indebted, even simply by the fact that the thinkers who later come and correct him are themselves responding to the kind of work that he's been about.
Yeah, and there's even an irony in that regard, because to mention another sort of urban legend, a lot of people will assume that the real motive behind the people that are geocentrists, right, that they think that the Earth at the center of the universe, is a kind of vanity, right, an assumption that we are the ones that are the most important thing in the cosmos, and so naturally we're going to assume everything's revolving around us. Whereas Ptolemy and Plato and Aristotle and the Greeks that were talking about the Earth being at the center of the universe said, no, it's the other way around. This is where all the dross of the universe settles, if you will, right? That we're at the center because that's where all the junk is. That's where all the things that corrupt by themselves are. Whereas everything that's out there is eternal and divine. That's the stuff that has the dignity. We're the leftovers, if you will, at the bottom of the universe. And so being at the center is it's not pride of place, right? So as I say, there's an irony there, because in a way what Copernicus does is, I don't know if he ever puts it this way, but he's elevated the Earth to the level of a heavenly body, right? Because
Yeah.
it now is orbiting around things moving in perfect circles, right? Whereas things don't move in perfect circles around here, it seems, right? Things move in straight lines, or they sit still, right?
Yeah.
Or maybe they trace out an arc when you toss them, but not a circle. Whereas there's a promotion involved in the Copernican hypothesis. It's not a demotion. People pretend the Copernican, the heliocentric revolution, pardon the pun, is being more humble about us. Well, we're just another planet, right? And whereas Copernicus is saying we're a planet, right? We're one of these stars, basically, or we're no different from them. You can think of it as a downgrading of the rest of the universe, I suppose, but in terms of regular circular motion, it seems like it's an upgrade for us.
Yes. Yeah, and what accompanies some of that on Ptolemy's side is that, okay, we're here among the corruptible things, the lesser things of the cosmos, so maybe the best option for us is the contemplative one.
Yeah.
Well, at least we have a kind of view that we can take.
Yeah.
And that's what we ought to order ourselves toward is contemplating reality, not focusing on ourselves, but on what's out there and on what can be learned. And you couldn't ask for a better model of the contemplative life in that sense.
Yeah, I think that's really right. That's beautiful.
All right, well, great.
All right,
Thank
thanks
you.
a lot, John.
Okay.